Today we're going to be solving systems of equations by substitution. There's a couple other ways, but this is the method we're using today, solving by substitution. And anytime we solve a system, we're solving for more than one equation. So here we have two equations. They would both make a line on a graph, if you know how to graph these. Okay, so they would make a couple of lines, and there would be very likely a point where they cross. Not always, but usually they're going to cross at some point, unless they're parallel. And what we're looking for is an XY ordered pair where the same X, if we were to plug it into both of these, and the same Y, if we plug into both of these, would make these simultaneously true. That's what we're always looking for when we solve a system by substitution. And substitution means we're going to sub one of the equations into the other. I call it surgically implanting one equation into the other. So the idea here is we know that the x and y's, we're looking for the point where they're equal. So we can assume this x is the same as this x and this y is the same as this y. And the first thing we want to do is isolate one of the y's or one of the x's. So I think I'm going to take this top one here, and if I subtract 2x from both sides, so 2x minus 2x is 0. So I've turned this into 0, so it'll be gone from this side. And this gives me y equals, and I think I'm going to put the negative 2x first, just because I prefer to have the x term first. It doesn't really matter. But this is the same thing as this part right here. Okay, well now I have isolated one of the variables. I solved for y. And here's what I'm going to do. I'm going to take this second equation here, and where there's a y, I'm just going to open up a space there. So this is just this equation, negative x plus y, which is this, equals 2. But looking at the equation we just solved for y, we can say that this y is the same as this y, because that's the point that we're forcing. This y is this y, and according to this, y is the same thing as this. This is y, and this is y. So here, where there was a y, instead of putting y, I'm going to put what y equals. And that's negative 2x plus 5. Okay, why did I do that? Why was that advantageous? Well, if you look at both of the original equations, we have an x and a y. Well, obviously, I can't figure out, if I only was looking at this top equation and I had no other equation, just this top equation here was all that existed, and I'm trying to figure out what are x and y. Well, if you think about it, they could be an infinite number of things. If you make x 1, y would be something. If you made x 2, y would be something else. You could do that forever and ever. You have no way of pinning down one value. But this equation now only has x's. There aren't two variables anymore, which means I can actually pin down the x value that would make both of these simultaneously true. And so that's the advantage of plugging one equation into the other, is you're actually eliminating one of the variables so you can just concentrate on the one that's left. So now we're going to solve for x. And so here we're distributing a positive 1. So positive 1 times negative 2x is just negative 2x. It doesn't change anything. 1 times 5 is 5. Okay, once we eliminate the parentheses, we combine like terms. Negative 1x, take away 2 more x's. That's going to be negative 3x's. Okay, now I want to get x alone. That's what this whole thing is about. So how do I undo addition by 5? Well, I take away 5, which means I have to do it to this side too. This is now 0. 2 minus 5 is negative 3. Now I want to get x alone. I've got it partially there, but I have this thing left over. X has been multiplied by negative 3. I undo that by dividing by negative 3. And now this just cancels into a 1, and we see that x equals 1. Okay, I now know what the x part is. The x part is 1. Okay, but now I need to figure out y. Well, that's pretty easy now. Now that I know what x is, we go back to either one of the original ones. So we're just looking at the yellow part now, the original system. And since I know what x is, I can plug it into either this one or this one, and I can figure out what y is. Since it's the same x and it creates the same y, it doesn't matter which one you plug it into. You'll get the same y. So pick the one that seems like less work. So I think since I know what x is, I'm going to plug it into this one. So now I have negative 1 plus y equals 2. Okay, well, how do I undo a negative 1? Well, I do it with a positive 1, which means I have to do it to this side. And now negative 1 plus 1 is 0. And now I get that y equals 3. And we have our xy pair that makes both of these original yellow equations true. Now, just to make the point, let's go ahead and let's test it. So here where the variables are, I'm going to put a parenthesis because I'm going to plug these in. So all I did was recopy the original system, and now we're going to test this point to see if it really makes both of them true. So according to this, x is 1. So there are the x's, and y is 3. Okay, is this true? 2 times 1 is 2. 2 plus 3 is 5. Yes, this one is true. What about this one? This is negative 1 plus 3, or when I see a positive and a negative, I like to say the positive one first. I'd rather think 3 minus 1. But you could think negative 1 plus 3 if you like. But 3 minus 1 is 2. And we have found the xy pair that would make both of these equations true. Okay, let's do another one. So, two equations, each have an x and a y, and I'm looking for the particular x and the particular y that we could plug into both of these, and it would make both of these simultaneously true. First step, solve for either x or y. Solve for means get it alone. Okay, so look at this and think, which one, I have an x and a y and an x and a y, which one would be the least amount of work to get alone? Well, it looks like this one would be the easiest. So here's what I'm going to do. So I'm going to add y to both sides. Okay, so now it's gone from this side. And so I have 4x equals 20 plus y. And now if I subtract 20 from both sides, I get y equals, this is just 0 now, 4x minus 20. And so I have what I wanted. I have one of the variables alone. Okay, so it's important to remember that whatever equation you use to solve for, you're going to use the other one to plug that into. Obviously, you're not going to plug the same equation into itself, or that would be pointless. Okay, so since I solved for y with this one, now I'm going to take this one, and we're going to do just like last time. I know that that y is the same as this. Okay, this y is the same as this y. This y is the same as this. So instead of y, I'm just going to put in the x term because I have an x term over here. So I'm just going to take this and I'm going to open it up. That's just this, except in place of y, I made a holding tank to put in this thing, which is the same thing as y. And so that's 4x minus 20. This is y. This equation is this equation. But the advantage is now I have only x's, so I can pin down x to a specific value. And now we just do the algebra. So this is going to be negative times a positive, 2 times 4 times x, negative times a negative, 2 times 20. Okay, we're almost there. I have to combine like terms. So if I have negative 2x's minus 8 more x's, now we're at negative 10x's. And I'm going to do two steps at once here. This 40, I'm going to bring it over here. I'm going to subtract the 40 from both sides. So now this is gone. And 10 minus 40 is negative 30. And last step, now really once you get to this point, I mean, just think about it. Negative 10 times what would equal negative 30? Well, that would be 3. But if you want to, do the algebra, we know we undo multiplying negative 10 times x by dividing by negative 10, which means we have to do it to the other. This now cancels into a 1, and we get that x equals a negative divided by a negative is a positive. 30 divided by 10 is 3. Okay, so we now know that the x part of the point we're looking for is 3. What's the last step? Well, it's pretty easy to get once you have one, it's pretty easy to get the other one. You don't have to do all of this again. I mean, you could, but what would be the point? I now know that x is 3. So pick whichever one of these seems like the least amount of work to plug x in, and I'm not really seeing that one is easier than the other, so let's just use this. So this is 4 times 3. So that's 12. So I'm going to rewrite it over here. 12 minus y equals 20. I think the easiest thing to do here, I'm going to add the y to both sides. And now I'm going to subtract 20 from both sides. I'm not really dwelling on the algebra here. I'm assuming that you're already getting pretty good at algebra if you're looking at systems. And we now know that, okay, so we had x minus 3, x equals 3 here. Here we have y equals negative 8, and so we now have the other one. So this is the point we were looking for. I'm not going to take time to test it and make the video longer, but if you wanted to, you could put 3 in for both of the x's here, put negative 8 in for both the y's in the original blue system here, and you would see that it would make them simultaneously true, and so we've done what we wanted to do. Okay, let's do another one. So first thing we do is we look for a variable to solve for, but look here, we kind of have a gift here. We already have one of the variables alone. So I don't need to do anything here. I don't need to isolate the variable. So let's go ahead and take this and plug it into this. So we're plugging in for y. Again, it could have just as easily been for x. Doesn't matter which one, whichever one seems the most convenient. Okay, well here I've written this, but I made a holding tank in the place of y because instead of y, which is the same as this y, we know we're solving for the point where the two y's are equal. This is equal to this, and this is the same thing as this. Well, this is y. So I'm just going to put this in here instead of y. Again, that makes all x's here, so now we can pin x down. So I'm just going to do this quickly now. I distribute here. I have positive 4x. I have negative 8. Okay, when I combine like terms, if I have 4x's minus 4x's, well, these just turn into 0. Okay, so that's a little weird if you haven't seen it before. And I just get left with a true statement. In fact, if I hadn't crossed this out, let me go back to what we had. What if I had said, okay, I'm going to add 4x to both sides. And so now we've gotten rid of it on this side, and we get So what's left is negative 4x minus 8 equals, and I'm going to switch the order here, negative 4x equal or minus 8. No matter what we do, you could do other things here. No matter what you do, you're going to get the same thing equals itself. You're going to get a true statement. Well, what does this mean about the value of x? What it means is that any x works. It wouldn't matter what number you put in for x, you're going to get equality here. You're going to get a true statement. So what does that mean when you run into something like this? Well, what it means is infinite solutions. Okay, it means that any XY pair that makes the first one true also makes the second one true. It's not going to matter. We don't even have to mess with the other variable now. Once we use one variable and we see that no matter what we do, we get a true statement, then at that point we know that the same thing's going to happen with the y. And so any XY pair that makes this true will also make this true, or vice versa. Whatever makes this true will make this true. And really what's happening here, if you clean these up and arrange them the same way, you're going to see that they're really the same equation. That's what's really going on. In other words, if these were both on a graph, okay, so you had a graph like that and one of them looks like that. Well, the other one, if you graph it too, it's just going to go right on top of it. They're really the same equation. They're not actually two different equations. And so I mean, obviously, whatever XY pair makes one true is going to make the other one true. And that's why you have infinite solutions. So be prepared to either have a single answer, which is an XY pair, or you might have, so that would be this case. If you have that, you're going to get one answer. If you have really where they're both the same equation, you're going to have infinite solutions. But the other thing that could happen is you could have parallel lines. And in that case, you're going to get no solution. So we're going to see one of those two. Okay, on this one, again, we have one of the variables already alone. So it seems like in all these examples, it's always been y, but it doesn't have to be. It could have been x, and then you could have substituted for x in the other. So don't think we're always substituting for y. That's just how all the examples that I happen to pick have been, but it's not always like that. Okay, so what we're going to do is I'm going to take this one and plug it in. I'm going to take this here, and I'm going to plug it in to this y. So we're going to take this bottom one here, and where y is, we're going to make a holding tank. And instead of y, we're going to put what we know y is equal to, which is 3x minus 5. So now I have to distribute. If it helps, you know, this is when you have a negative in front of a parenthesis, if it helps, you put a 1 there because a negative is really the same as a negative 1. Okay. So this is going to be a negative times a positive, 1 times 3 times x. Negative times a negative is a positive, 1 times 5. Okay. Well, look what happens when we combine like terms here. Those just go away. And we are left with 5 equals negative 2. Well, you know, if you check that you didn't make a careless mistake, but you still get an absurd statement like this, that tells you that there is no, no solution. Okay. So, remember, absurd statements give you no solution. If no matter what you do, you get a true statement like this, or this, or this, whatever. You keep getting true statements, that means infinite solutions. But if you get stupid statements like 5 equals negative 2, which is impossible, you know there is no solution. What is actually going on here is these two equations, if you graphed them, Okay, and I don't know what they look like, but you know, I'll just do an example like that. If you graph them, you will see that they are parallel. They have the same slope. Well, since they never touch, there's never going to be an XY pair that make both of them true at the same time like there would be if they actually crossed. And then there is that one point where the same X and Y make both of them true. That can't help and that can't happen if the lines are parallel. Okay, and so that is how you solve systems of linear equations by substitution. I'm going to do another video on solving by elimination. Hope this helps.